morning, students. We are learning about triangles, and today we are going to start with the properties of inequalities of sides. Okay, so properties of inequalities. Inequalities means these sides are not equal. Okay, so if the two sides of a triangle, okay, are unequal, then the angle opposite to them, the greater side, okay, this is the greater side out of this, okay, and this side is smaller, so angle opposite to this is this angle. So we need to show that this angle is greater than angle opposite to smaller side. Okay, so let's write down the theorem first. So this is the theorem. If two sides of a triangle are unequal, then the angle opposite to the greater side is greater than the angle opposite to the smaller side. So to prove, you have to write what from the diagram, that the angle XYZ, okay, is greater than angle XZY, right? But to prove this, we need to construct. So write down in construction. Take a point P on side. Now we are going to take point P on this side, XZ. Such that this point should be in such a way that this XY, okay, should be equal to XP. More? Okay. So this side should be equal to this side. Here is point P. Okay. So let's prove. To prove, before proving this, I want you to write down whatever is there on the board. So you can pause the video and write down, and then we'll move towards the proof. Okay. So we are going to start with our proof. Okay. First, we will talk about the triangle XYP. This smaller triangle we will talk about. Okay. So we have constructed this line and P, point P, okay, and what we have done it in such a way that these two sides will be equal. So I am going to write that the segment, or you can just say side, okay, segment, or just say side XY is equal to side XP. This is from construction. You have to write fully, okay, I don't have space, so I'm not writing that. And then we can also say that this angle, okay, XYP and XPY are congruent. How? Just think about it, how XYP is congruent to angle XPY. Because we have learned in the theorem of isosceles triangle that if the two sides are equal, that means if the triangle is isosceles, these two sides are congruent, therefore the angles opposite to them are also congruent. So this is isosceles triangle theorem. Okay, I hope you have got it. Okay, now from this, what else you can say? Okay, that if you talk about this angle, this will be the interior, right? Yes. So angle YXPY is an exterior angle of triangle PYZ. Now here you have to use exterior angle theorem, and the theorem says that this angle, exterior angle, that is xpy, will always be greater than these two angles of the triangle, right? So that means this angle xpy will be greater than, I am just going to talk about this because I need to prove that this is greater. So angle P YZ, okay, from exterior angle theorem. Now whenever I am going to add anything to this, if I am saying angle A is greater than angle B, and if I am adding angle A plus something to that angle, it will always be greater than B, right? Do you agree with this? If you agree with this, then if I add a little angle to this side xpy plus angle pyz, plus angle pyz, this all will be greater, yes, so this all will be greater than this smaller angle, right? Angle PZY, okay, angle PZY, and that's what we want to prove, right? That this angle, because this angle XPY, this angle XPY means angle XYP plus angle PYZ together forms angle XYZ, this whole angle, okay, and it is greater than angle PZY. I hope you have understood. Just while writing, don't get confused about this. This is for angle and this is greater than sine, okay. Here it is also like that. This is angle and this is greater than cosine, okay. So I want you to write down all this. We have proved the property of inequality of sides and angles of a triangle. Whenever you will be given a triangle with two different sides, you have to prove that this angle is always greater than that angle. So angle opposite to the greater side will always be greater than the angle opposite to the smaller side, okay. I hope you have clear. If you have still doubts, then you can definitely ask me, okay. So that's it for today.